Okay, students, I am making a video of our review that I handed out today. You guys did, most of you did the first page and some of you got well into the second page. But I made the video and I'm going to go through each problem. Probably the first page of problems 1 through 6, I'll go a little bit faster since you've done most of those. But if I go too fast, just pause it and rewind it and listen again, or pause it whenever you need to. I'm going to go fast because you can pause and rewind if you need to listen something again. But in this way, it will be a short video for you. So on problem number 1, you were supposed to fill in the missing values of the table based on the growth that is described. And it says the growth in the table is triple at each whole year. We explained that, but we had to fill in the ones that I'm circling in blue right now, which is all the rest of them down the line. And we found out that the multiplier is just the square root of 3, or 3 to the 1/2. So if you multiply each one by square root of 3. Now the way we figure that out, and we look at the explicit equation right here that I'm underlining, 2 times 3 to the x. And the way we figure that out is since it's tripling from 2 to 6, from 6 to 18 between the whole numbers, 18 to 54, we know that 3 is going to be our base. So we have 3 right there. And we know that it's going up a power of x each time, okay, because it's an exponential function. It's geometric. And since the first term happens to be the 0 term, the 0 term right here is 2, we know that we had to put a 2 out here because 3 to the 0 power is 0. 3 to the 0 power is 1. Anything to the 0 power is 1. And you times it by 2 to get that first term. And then we know we're going to substitute 1/2 in because that's the next power. So 3 to the 1/2 power is just the square root of 3. So 2 root 3 is our next term. And then we put 1 in there. 3 to the 1 power is 3 times 2 is 6, which is our first term right here, number 1 term, which is really the third in the sequence. And if we put in 3/2 power, 2 times 3 to the 3/2 power, that is 2 times the square root of 3 to the 3rd. Well, we already know that that means 2 times root 3 times root 3 times root 3. And we know that when we times the first two root 3's together, root 3 times root 3 is root 9, which is 3, times the root 3 that's left at the end. So 2 times 3 is 6, root 3. And that's how we got the 3/2 term. And you just continue doing that. Or just think of it as multiplying each next term by root 3. And you'll get it. Okay, so that was the first one. We went over that one in class already, so I'm not going to spend any more time on it. Okay, problem number 2. I've already written the answer to this one. Okay, remember that 2, the bottom number, goes right here, and you don't have to write it in if it's a square root, because we just know it's a square root if the radical's there and there's no number written in. And the power, 5, goes right here, so it's the second root of x to the 5th. On part B, we have the radical given to us. We're supposed to write it as a rational exponent. So once again, that number goes on top, and this number goes on the bottom. So y to the 4/3. You guys all did that one. Number 3. Some of you struggled with this one. So we have the cube root. So we're looking for triplets. And we break it down in its prime factors. And right here I've written down the prime factors, and they happen to be 2 times 2 times 2 times 3 times 3. Well, the 3 2's, that's a triplet. And if you times them together, you get 8. And the cube root of 8 is 2. And that's why we just got a 2 right here. Okay, in other words, you just take one of the triplets and put it outside. And then the 3's, there's only 2 of them. There has to be 3 of them in a cube root. And there's only 2 of them. So we times them together and put them inside. So we showed 3 times 3 right here, and we put them inside the radical. So 2 cube root of 9 is the answer. That right there is the answer. Okay, problem B right here on number 3. We were given that we were doing the square root of 600. So since it's a square root, we're looking for pairs. When we broke it down as prime factors, we had a pair of 2s. I'm going to use a different color here. We had a pair of 2s. We had a pair of 5s. And we had a loner 2 and a loner 3. So we take one of the 2s and put it outside, one of the 5s and put it outside, because 2 times 2 is 4, and the square root of 4 is 2. That's where we got that 2 from. And 5 times 5 is 25. The square root of 25 is 5. That's why they go outside. We've taken the square root of them. And then the loners, 2 and 3, go back inside. So 2 times 5 is 10. 2 times 3 is 6. So our answer is 10 root 6. Once again, if I'm going too fast, just pause it, rewind it, look at it again. Okay, number 4. On number 4, you had to change this to radical form. Okay, well, we know that if the bases are the same, which they're both 5, and we're multiplying, which we are, then all you have to do is add the exponents. So the 2/3 and 5/3 are the exponents, so it's 5 to the 2/3 plus 5/3. That's one of our rules of exponents we learned. You actually learned it in Secondary Math 1. We're just using it with rational exponents. And so 5 to the 7/3, because 2 plus 5 makes 7, so it's 5 to the 7/3, which now we change to a radical. The 3 is the index, the bottom number is the index, and that number goes as a power. So the cube root of 5 to the 7th was the answer. Okay, on part B, we have the 5th root of x to the 12th times y to the 7th. And so we can just separate that. We can just put the 5 under the 12 right here to get x to the 12/5 and y to the 7/5. The 5 goes on the bottom. It's the index. Okay, next problem. Number 5. Number 5 asks you provide 3 other equivalent forms of the exponential expression. So we have 3 to the 12th power. Well, it wanted us to use this rule right here, that if the bases are the same, you're multiplying, you add the exponents. So 3 to the 6th times 3 to the 6th is 3 to the 6th plus 6, which is the 3 to the 12th. So this is one form that we can use. The second one's a power to a power. When you have a power to a power, you multiply them together. So 6 times 2 is 12. So that's why that one's equivalent to 3 to the 12th. And the last one, division, remember that's 3 to the 14 minus 2, which is 3 to the 12th. So these are just 3 examples. There's, hundreds. There's thousands there's an infinite number of ways to write 3 to the 12th using powers like that. Okay, part B. Okay, 4 to the negative 6th power. Well, if I'm using the rule of multiplying with the same bases, then 4 to the negative 8 times 4 to the 2 is 4 to the negative 8 plus 2, which if you add negative 8 and 2, you get 4 to the 6th. So that's where we get that. I should separate this with a green line. Okay, 1 over 4 to 6. We know that if you have a negative exponent right here, all you have to do to get rid of the negative exponent is move the 4 to the 6th to the denominator. So it's 1 over 4 to the 6th. Those are equivalent expressions. That was one of our laws of exponents. Okay, and 4 to the 2nd power to the negative 3 power, it's power to power, so you multiply 2 times negative 3 and you get 4 to the negative 6 power as well. So there's 3 different forms of 4 to the negative 6. Right here on this last one, once again, we know that 5 to the 1/3 times 5 to the 1/3 is 5 to the 1/3 plus 1/3, which is 5 to the 2/3, so that one works. Okay, when you're dividing, it's 5 to the 4/3 minus 2/3. And we know 4/3 minus 2/3 is 2/3. So once again, we get 4 to the 2/3. I'm sorry, 5 to the 2/3. I was back on the last problem. 5 to the 2/3 is our base. 5 is our base, not 4. And then this one right here, the last one, is power to power. So if you multiply 1/3 times 2, well, when you times a fraction by a whole number, I multiply the whole number by the numerator. So 5 to the 2/3 power. So that's what we get there. Okay. Problem number 6. Number 6, you need to determine whether all three expressions in each problem below are equivalent. Well, if we use our rules of exponents that we just learned, we know that this 2 to the x plus 2 power can be written as 2 to the x times 2 to the second power. And really, we don't need the parentheses anymore. Okay? We didn't need them in the first place. Well, other than implied multiplication. But we have 50 times 2 to the x times 2 squared, which is 4. And now multiplication can be done in any order that we want. And so 50 times 4 is 200 times 2 to the x power. That's as far as that can be simplified, because in order of operation, raising a number to a power comes before multiplication. And so we'd have to go 2 to the x before we could go 200 times 2 because of order of operation. And since we don't know x is, this is simplified. So we need to go over the other two to see if they're equivalent to it. Well, using that same rule that we just learned, 25 times 2 to the 2x times 2 to the 1 power. Well, 2 to the 1 power is just 2, and 2 times 25 is 50. So we have 50 times 2 to the 2x. Well, we could separate that and go 2 squared to the x power, because that's the same thing. It's power to a power. 2 times x is the same as power to power. So we could write 2 squared as 4. So it's 50. I'm going to write it below it. It's 50 times 4 to the x. And once again, that's simplified because I have to do 4 to the x before I can go 50 times 4 because of order of operation. And you can see that that one's equivalent to that one already. That one's simplified. So those two are equivalent, but these two are not. Not equivalent, but these two are equivalent. So not all three of them are equivalent to each other. So we check that. Okay, part B. All right, on this one right here. Well, first of all, I have 8 times 1 over 3 to the x power. Because anytime you have a negative exponent, you can move it to the denominator and make it a positive exponent, so it's 1 over 3 to the x. Well, 8 times 1 is 8 over 3 to the x. Well, that's the same as this one. And this one over here, we could rewrite this as 8 times 1 to the x power over 3 to the x power. Well, we know 1 to any power is going to be 1. Doesn't matter what the power is. So 1 to any power is going to be 1. So we have 8 times 1 over 3 to the x. And once again, if I multiply 8 times 1, I get 8 over 3 to the x. So all three of these are 8 over 3 to the x power. I'm sorry, 8 divided by 3 to the x power. All three of those are equivalent. Okay, problem number 7. Problem number 7 on the back side. Some of you didn't make it this far on the review. So, a couple of groups that didn't. Some of you groups got almost all the way done. So this is right here. The instructions on this one is use the given function to find the missing values. Check your work using a graph. So, well, first of all, it wants me to find f of 0. That's just putting 0 in for x. Well, we all know that that's just going to be negative 24. So there's my answer there. Next one, f of 2, means I'm going to substitute 2 in. 2 squared plus 5 times 2 minus 24. Well, that one's going to be 4. That's going to be 4 plus 10 minus 24. That's 14 minus 24 is a negative 10. So that's negative 10. Okay. And then we're supposed to find f of x equals 0. That means replacing f of x with 0. So 0 equals x squared plus 5x minus 24. Well, that is a quadratic equation, so I'm going to need to solve that either by factoring, completing the square, or quadratic formula, or graphing, or some other method that we have used, making a table of values. Well, I am looking at this one, and I can see that 3 times 8 is 24. Negative 3 times 8, I can see right here that negative 3 times 8 equals a negative 24, and at the same time, negative 3 plus 8 equals a positive 5, which is this middle term. So, and this was this term right here. So it factors. You're welcome to use the quadratic formula if you want. So I know that this factors to be x minus 3 and x plus 8 equals 0. I know that if I set each factor equal to 0, I will get x equals 3 and x equals negative 8 as my two solutions for x. That's also, if you remember right, where the graph of the parabola will cross the x-axis. So if you graph this, it should cross at negative 8, 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3. And this thing opens up. We've talked about that before, and negative 3, so it's going to look something like that. Okay, and our last part right here, well, if you notice, f of x equals negative 10. Okay, so we are going to replace f of x with negative 10. I'm going to do this right over here. So it's negative 10 equals x squared plus 5x minus 24. Well, that's a quadratic equation too. It's not equal to 0 yet. So to solve it, we're going to add 10 to both sides to get it equal to 0. And that's going to give us 0 equals x squared plus 5x minus 14. And we can solve that. We can see if it factors, and it does, because I can see that negative 2 times positive 7 would make a negative 14. And I can also see that negative 2 plus 7 equals 5, which is the middle term. So negative 2 and 7 are my two answers. So x minus 2, x plus 7 equals 0. So I said x minus 2 equal to 0, x plus 7 equal to 0. So my two solutions are x equals 2 and x equals negative 7 if I solve those two equations. And so if we replace f of x with negative 10, then I get 2 and negative 7 as my solutions. That is number 7. Remember, if I'm going too fast, to rewind, pause, whatever you need to do. Okay, and I would suggest you try some of these on your own first and then look to see how I did them. Okay, number 8a. This one is asking us to solve each quadratic equation below. And what I mean by that is use whichever method you think is best. You can use the quadratic formula on this one. However, this one factors pretty easily. We know that two numbers we can times together and get 21 are 3 times 7 equals 21, right? And that those two numbers, 3 plus 7, equal 10, the middle term. So my two numbers are x plus 3, x plus 7 equals 0. Set each factor equal to 0, and I get x equals negative 3, and x equals negative 7 is my two solutions. Okay, the next one. I'm looking at that one. 4 times 12 is 48. And 4 times a negative 12, so I think it's 4 times negative 12 equals negative 48, so this one factors as well. And 4 plus a negative 12 is a negative 8, which is the middle term, so this one factors as well. But once again, you can use the quadratic formula if you feel more comfortable doing it. I just think it's so much faster if you can do it this way. So my two numbers are x plus 4 and x minus 12. So your solutions are negative 4 and positive 12. Okay? Part C. Part C, this one right here, you'll notice that there is no constant term. You have x squared, and that's the quadratic term. You have 4x, which is the linear term, but there's no constant term. Well, the best way to do this one is to factor out a greatest common factor. You'll notice that there's two x's in this term and one x in this term, so I can factor out an x. That would leave me with x minus 4 equals 0. Well, if I said each factor equals 0, first of all, factor of x, that one equals 0, so there's one of my solutions. And x minus 4 equals to 0 would be x equals 4. And so those are my two solutions there. That one's pretty easy to do by factoring out the greatest common factor. This last problem right here requires us to, well, notice that the linear term is missing, so b is missing, well, because it's 0. And so the best way to do this one, the fastest way, is just to solve it outright. I add 15 to both sides. Take the square root of both sides, and I get x equals plus or minus. Don't forget the plus and minus. Anytime you take the square root of x squared on one side, the other side is going to be plus or minus the square root of 15. Now, I need to check to see if that simplifies. Well, you know that 15 breaks down to 3 and 5, and those are both prime numbers, which leaves me with two loners. There's no pairs, so that one doesn't simplify, and my solutions are simply x equals plus or minus the square root of 15. Remember to pause if you need to go back and look at some of these. Okay, the next one. Whoops. The next one, number 9. Once again, I'm supposed to solve each quadratic equation using the most efficient method and state the method. Well, the most efficient method is whichever one works for you. I'm looking at number A, and I bet you it factors, but I'm going to do one by using the quadratic formula because we haven't done very many of those, and some of you guys need it. So we know that A is 3, B is 5, and C is negative 10. And so we are going to put those inside the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, is the quadratic formula. So if I substitute those in, negative b would be a negative 5 plus or minus the square root of b squared. Well, 5 squared is 25 minus 4 times 3 times a negative 10, all divided by 2 times a. 2 times 3 is 6. If I just go down below right here, I have negative 5 plus or minus the square root of 25. And negative 4 times 3 is negative 12, and negative 12 times negative 10 is a positive 1, positive 120. Am I getting those numbers right? 25 minus 4 times a, which is 3, times c, which is negative 10. That's right. Okay, so, and 4 times 3 is a 12. It's a negative 12 times a negative 10 is a positive 120. Whoops. Twice. Plus 120, all divided by 6. So 25 plus 120 is 145. So I have negative 5 plus or minus the square root of 145 all over 6. And I need to see if 145 breaks down. So I'm going to write that right over here. 145 prime factors. I know that 145 breaks down to 5 times 29. They're both prime numbers. Therefore, it is simplified. It doesn't simplify any further than that. So we had to use the quadratic formula for that one, or completing the square. So my two answers are negative 5 plus or minus the square root of 145 over 6. Right there. Okay, next one. B. This one right here, I am going to do this one by the quadratic formula as well. So I need to minus 6 from both sides of the equation to get it equal to 0, which I just did. And I know that A is 1. Oh, by the way, this one factors really nicely. Let's factor it. So two numbers I can times together and get negative 6 and add together to get 5 would be 6 times negative 1. 6 times negative 1 is a negative 6. And 6 plus a negative 1 equals 5. So this breaks down into x plus 6 times x minus 1 equals 0. So I get x equals negative 6 and x equals 1. Those are my two solutions to that problem. So factoring would be the most efficient method with that one, but you can do the quadratic formula. Okay, this one I can tell there's no two numbers I can get times together and get negative 4 and add together and get 8. So we're going to have to use completing the square or using the quadratic formula. This one actually works really nicely for completing the square, because anytime the coefficient of of x squared, or the a coefficient, is 1 and b is even, you can do this really nicely. So what I do is I have x squared plus 8x plus, I leave my blank right there and I add 4 to both sides to get rid of the 4 on the left side. So negative 4 plus 4 is 0, and 0 plus 4 is 4. So I've got this set up. Remember, I take half of 8, which is 4. 4 squared is 16. So that's 16. Whatever you do to one side, you do to the other. So 16 completed my square on my left side. So I know that 4 times 4 is 16, and 4 plus 4 is 8, which is a perfect square trinomial, so they factor into x plus 4 and x plus 4 equals 20, because 4 plus 16 is 20. And the short way of writing that is x plus 4 squared equals 20. And if I take, I'm going to move this up. If I take the square root of both sides of this, I get x plus 4 equals plus or minus the square root of 20. And I know that 20 breaks down into 4 and 5, and 4 breaks down 2 and 2. I have a pair of 2s, a loner 5. So this is going to break down if I minus 4 from both sides. So I get x by itself. I get negative 4 plus or minus 2 root 5. And that right there is my solution. Now, you could have used the quadratic formula for that one, and you should have got the same exact answer. So either way, you could have gotten that answer. Okay, this one down here will also work nicely completing the square, but I'm going to do a quadratic formula since we just did that other one that way. I know that 1 times 10 is 10, and 1 plus 10 doesn't add up to 6, and I know that 2 times 5 is 10, and 2 plus 5 does not add up to 6. So I need to solve this one, and I made a mistake on this one. This one is going to have a negative solution. I didn't want any of those yet. That's in our next lesson. But what we have right here is we're going to minus, well, we're going to get what we call imaginary solutions, which is the next lesson. But we can still do it using the quadratic formula, because A equals 1, B equals 6, and C equals 10. So I'm going to go x equals negative b would be negative 6 plus or minus the square root of 6 squared is 36 minus 4 times 1 times 10, which is 40, all over 2a. 2 times 1 is 2. Well, you'll notice that 36 minus 40 is a negative number. And the square root of a negative number, if you take the square root of a negative number, you're going to get an imaginary number, not a real number. That's why it's next lesson. But the square, I'll just show you really quickly. The square root of negative 4 breaks down to the square root of negative 1 times the square root of 4 all over 2. We know that the square root of 4 is 2. And For your information, the square root of negative 1 is the imaginary unit I. And so this actually breaks down to 6 plus or minus. The square root of 4 is 2, so 2. And the square root of negative 1 is I, so I all over 2. And 2 will go into both of those. It will go into negative 6 3 times, and it will go into 2 1 time, so 1I. So your answer for this one is actually negative 3 plus or minus I. Not much different than what we're doing, but that's what we'll be learning next. Don't worry about one of those on the test. There won't be one. If there is, it'll be extra credit. And number 10, last one, systems of equations. You learned about solving systems of equations in secondary math 1, and we've touched on it here recently. But this time, instead of having two linear equations, you have a linear, because that's x to the first, and a quadratic, because that's x to the second. So we know the answer, we're going to have a parabola and a line. There's going to be 2 points where they cross, and that's what you're looking for in a system of equations. You could actually do this by graphing, but I told you to do it by an algebraic method. So this one's quite easy because they're both equal to y, so we can use the substitution method. Since y equals x plus 6 and y equals x squared minus 2x minus 8, that means x plus 6 is equal to x squared minus 2x minus 8. They're both equal to y, so they're equal to each other. We have a quadratic equation. To solve the quadratic equation, you get everything equal to 0. So I'm going to minus an x and minus a 6 from the left side. I put it under its like terms, and I get 0 equals x squared minus 3x minus 14. You'll notice that that's just like all the other equations that we've been solving. So we're going to use the quadratic formula for this one. And here we have 0 equals x squared minus 3x minus 14. We are going to come up here, and we know that a equals 1, b equals negative 3, c equals negative 14. And we have the quadratic formula, so we're going to have x equals negative b, which would be a positive 3. Square root of negative 3 squared is a positive 9. Minus 4 times 1 is 4 times negative 14. So 4 times negative 14 is negative 56 all over 2 times 1, which is 2. And 9 minus the negative 56 is the same as 9 plus 56, which is 65. So 3 plus or minus the square root of 65 all over 2. And I know that 65 doesn't simplify because 5 times 13 is 65, and both of those are prime numbers. So your two solutions are x equals 3 plus or minus square root of 65 over 2. Now, I probably won't give you one like this on the test. In fact, I won't give you one like this on the test. You'd have to get those as decimals. So I'm going to get those as decimals. Okay, I put those into my calculator. I paused this for a second. Put those in my calculator, and I got x when I did 3 plus the square root of 65 divided by 2. Okay, and make sure if you put it in your calculator, you either put parentheses put parentheses around that before you hit divided by 2, or do the 3 plus square root of 65, hit enter, and then hit divided by 2, and you will get 11.062. And then the second time I went 3 minus the square root of 65 divided by 2. And I got negative 2.531. Those are my two x coordinates. And I got to see if I can move this stuff down. Okay, so we are going to go back up and plug those in one of the equations. Well, the easiest equation, I always do the easiest equation, which is the linear equation. Y equals x plus 6. I'm going to put those in there. So y is equal to x plus 6. Well, the first time I'm going to put 11.062 plus 6, and that's going to give me 11 plus 6 is 17, 17.062. And the next time I'm going to put negative 2.531 plus 6, and that's going to give me 3.469. Okay, so my two solutions are 11.062, comma 17.062, and negative 2.531, comma 3.469. Those are the two places that if you graph those on your calculator, that's the two of those two lines, or that parabola and that line, they would intersect at those 2 points. 11.062, comma 17, and negative 2.513, comma 3.469. Okay, and the last one is similar to it. Just once again, negative x plus 1 equals negative x squared plus 4x plus 10. I'm going to add x to both sides, minus 1 to both sides. Remember, put them under their like terms on the left side. So you get 0 equals negative x squared plus 4x, no, plus 5x, plus 5x plus 9. And guess what? I don't like having my x squared term negative. So I'm going to times both sides by a negative 1. And that's going to give me x squared minus 5x minus 9, which is an equivalent equation. And so I'm going to use that and solve that one. I know that that one doesn't factor because 3 times negative 3 is negative 9, but they don't add up to negative 5. Either does 1 times 9. So I have to use the quadratic formula here. And I'm going to go negative b would be 5 plus or minus the square root of b squared, which is 25, minus 4 times 1 times negative 9. 4 times negative 9 is negative 36, all divided by 2. And 25 plus 36, that's going to be 61. So 5 plus or minus the square root of 61 over 2. Once again, I'm not going to do this part for you. Put that in your calculator. Get the decimals. You're going to get two x numbers. 5 plus the square root of 61 divided by 2, and 5 minus the square root of 61 divided by 2. Get those two numbers. Plug them in to, I would plug them into the linear equation, this one right here, y equals negative x plus 1. Get the y numbers, and then you are set. And this is going to be worth 10 points on Tuesday. It's worth 2 assignments instead of 1 assignment. And we're taking the test, so you want to make sure you have it all done and you understand how to do all these problems. And we will see you then.